Standard 7th, Subject Maths, Chapter 13, Pythagoras Theorem. In the previous practice set, you learned how to solve sums based on Pythagoras Theorem. Now let us learn about Pythagorean triplet. Let's learn. If in a triplet of natural numbers, the square of the biggest number is equal to the sum of the squares of the other two numbers, then the three numbers form a Pythagorean triplet. If the lengths of the sides of a triangle form such a triplet, then the triangle is a right angled triangle. For example, do the following numbers form a Pythagorean triplet? 7, 24, 25. So these three numbers are given to us. They are natural numbers. So if in a triplet of natural number, if the square of the biggest number 25 is the biggest number, if its square is equal to sum of the squares of the other two numbers are 7 and 24. That means when we add the squares of 7 and 24, whatever answer we get, if it is equal to the square of 25 square, then these three numbers are said to be a Pythagorean triplet. So let's check. First, we will have to write the squares. So 7 square is equal to 49, 24 square is equal to 576, and 25 square is equal to 625. Now we will add the squares of the smaller numbers. Square of 7 is 49 and square of 24 is 576. 49 plus 576 gives us 625. Now we can see that the squares of the smaller two numbers when added is also equal to the square of the bigger number. That means we can write as 7 square is equal to 24 square. 7 square plus 24 square is equal to 25 square. This is the statement given here. That is, the square of the biggest number is equal to the sum of the squares of the other two numbers. You can see here, the square of the biggest number 25 is equal to the sum of the squares of the other two numbers. So we can see that 7, 24 and 25 is a Pythagorean triplet. Now an activity is given in your textbook on page number 90. From the numbers 1 to 50, pick out the Pythagorean triplets. So the solution we have here, 7 triplets are listed. You can write it down in your notebook as an additional activity. 3, 4 and 5 is a Pythagorean triplet. Similarly 5, 12, 13. 7, 24, 25. 8, 15, 17. 9, 40, 41. 12, 35, 37 and 20, 21, 29. All these sets of numbers are Pythagorean triplets, and if you have to construct a triangle with these sides, it will be a right angled triangle. So a triangle with sides which form a Pythagorean triplet is always a right angled triangle. So now let us begin with practice set 49. Question 1. Find the Pythagorean triplets from among the following sets of numbers. So here we have sets of numbers. 6 questions are given to you. One by one we will solve and check whether they form Pythagorean triplet or no. So first sum, the numbers given are 3, 4 and 5. Our first step is to write down their squares. So we write down the solution. 3 square is equal to 9. 4 square is equal to 16 and 5 square is equal to 25. The second step is to add the squares of the smaller numbers. So 3 square is 9 and 4 square is 16. So which two numbers we shall add? Yes, 9 plus 16. So now 9 plus 16 gives us 25. Now check the square of the biggest number. 5 square is also 25. That means we can say that 3 square plus 4 square, it's shown 42 by mistake here, it's 4 square. Okay, 4 raised to 2. 3 square plus 4 square is equal to 5 square. Hence, 3, 4 and 5 is a Pythagorean triplet. So with this steps, you can prove that whether the given set of numbers is a Pythagorean triplet or not. So same steps we will follow for all the 6 questions. Second sub question is 2, 4, 5. First, the squares. So we write 2 square is equal to 4, 4 square is equal to 16 and 5 square is equal to 25. In the second step, we will add the squares of the smaller numbers, that is 4 plus 16, which is not equal to 25. 4 plus 16, if you add, you get 20. You can write 4 plus 16 is equal to 20 and show that it is not equal to 25. Or straight away you can write in this step 4 plus 16 is not equal to sign and one slash means not equal to 25. The third step, that means 2 square plus 4 square is not equal to 5 square. Therefore 2, 4 and 5 is not a Pythagorean triplet. So in simple steps we have shown that 2, 4 and 5 is not a Pythagorean triplet. Same steps. You have to show whether it is equal to or not equal to the square of the bigger number. Third sum, 4, 5, 6. So first step, we will write the squares of all the 3 numbers. 4 square is equal to 16, 5 square is equal to 25 and 6 square is equal to 36. Now add the squares of smaller numbers. 16 plus 25. 16 plus 25 is not equal to 36. It gives you 41. 20 plus 10, 30, 36 plus 5, 41. That means it is not equal to 36. So we will write down 4 square plus 5 square is not equal to 6 square. Therefore, 4, 5 and 6 is not a Pythagorean triplet. Okay. Here, if you don't show the actual answer 16 plus 25 is equal to 41 is also okay. You can just show that 16 plus 25 you add in your rough and then check if whether it's equal to 36. If not equal, write not equal to 36. Then you write 16 plus 25 is whose square? 4 square plus 5 square. Therefore 4 square plus 5 square is not equal to 36 is whose square? 6 is not equal to 6 square. And then the final answer. Okay. Next question number 4. 2, 6, 7. Let's write down the squares. 2 square is equal to 4. 6 square is equal to 36. 7 square is equal to 49. Now we shall add which squares? Square of 2 and square of 6. That is 4 plus 36 is not equal to 49. 4 plus 36 should give us 40. So it's not equal to 49. That's why we can write 2 square plus 6 square is not equal to 7 square. 4 is what? 2 square. So 2 square. 36 is what? 6 square. So we write 6 square. And 49 is whose square? 7 square. So we write 7 square. 2 square plus 6 square is not equal to 7 square. Therefore, 2, 6 and 7 is not a Pythagorean triplet. Question number 5. 9, 40, 41. Let's write the squares. 9 square is equal to 81, 40 square is equal to 1600 and 41 square is equal to 1681. 41 into 41 you will get 1681. Now add the smaller two squares, that is 81 plus 1600 will give us 1681. If you compare, you will see that both are equal. So you can write down that 9 square plus 40 square is equal to 41 square. Therefore, 9, 40 and 41 is a Pythagorean triplet. So this way we can get an answer whether it is a Pythagorean triplet or not simply by writing the squares and adding the smaller squares and checking with the bigger number square. This way we can detect whether it is a Pythagorean triplet or not. Sixth question, 4, 7, 8. Now the squares. 4 square is equal to 16, 7 square is equal to 49, 8 square is equal to 64. 16 plus 49 is not equal to 64. Therefore, 4 square plus 7 square is also not equal to 8 square. Therefore, 478 is not a Pythagorean triplet. So this way we have completed question number 1, sub question 6 altogether. Let's move on to question number 2. The sides of some triangles are given below. Find out which ones are right angle triangles. Now, if we know the angle, we can say that it is a right angle triangle or no. But by looking at the sides, how to detect whether it is a right angle triangle or no? Yes, we can do it by the use of Pythagorean triplets. So we will first have to identify whether the given triplets are Pythagorean triplets or not. If they are Pythagorean triplets, then it is a right angle triangle. Okay, these are the sides of some triangles. So let's do it one by one. Question number 2, sub question 1, 8, 15, 17. So the same steps. 8 square is equal to 64, 15 square is equal to 225 and 17 square is equal to 289. On adding the squares of the smaller numbers, we get 64 plus 225 is equal to 289. Now we can compare and see that both are same. So we will write 8 square plus 15 square is equal to 17 square. The above expression is of the form hypotenuse square is equal to base square plus height square. Therefore, the sides of lengths 8, 15 and 17 will form a right angle triangle. The only difference in question number 2 is you are going to write in this pattern. This is the statement you are going to write. The above expression, this expression is in the form of hypotenuse square, that is 17 square is equal to base square plus height square. And this formula is Pythagoras theorem of a right angle triangle. So now we can say that the sides of lengths 8, 15, 17 will form a right angled triangle. So note down the steps carefully. Second sum, 11, 12, 15. Let's write the squares. 11 square is equal to 121, 12 square is equal to 144, 15 square is equal to 225. But 121 plus 144 is not equal to 225. You will add in the rough and check for yourself. Therefore, we can write 11 square plus 12 square is also not equal to 25 square. So, not 25, here it should be 15 square. In the question we have 15. Here also we have 15 square. So 11 square plus 12 square is not equal to 15 square. Next, the above expression is not of the form hypotenuse square is equal to base square plus height square. Therefore, the lengths of sides of lengths 11, 12, 15 will not form a right angle triangle. So, for question number 2, all sub questions you will have to write the last half part in this manner. The above expression is of the form or not of the form. Hypotenuse square is equal to base square plus height square. And accordingly you will write your answer whether it will form a right angle triangle or not. Third, 11, 60, 61. 11 square is equal to 121, 60 square is equal to 3600 and 61 square is equal to 3721. Now 121 plus 3600, that is the addition of squares of smaller numbers, is equal to 3721. And the square of greater number 61 is also 3721. So we can say that 11 square plus 60 square is equal to 61 square. Now a statement comes. The above expression, that is 11 square plus 60 square is equal to 61 square, is of the form hypotenuse square is equal to base square plus height square. Therefore, the sides of length 11, 60, 61 will form a right angle triangle. Fourth sub question, we have 1.5, 1.6 and 1.7 as the sides of a triangle. Let's find the squares. 1.5 square is equal to 2.25, 1.6 square is equal to 2.56, and 1.7 square is equal to 2.89. On adding the squares of the smaller numbers, we get 2.25 plus 2.56, which is not equal to 2.89. Therefore, the squares are also not equal. 1.5 square plus 1.6 square is also not equal to 1.7 square. Therefore, the above expression is not of the form hypotenuse square is equal to base square plus height square. Therefore, the sides of lengths 1.5, 1.6, 1.7 will not form a right angled triangle. Question number 5. 40, 20, 30. So, let's write down the squares. 40 square is equal to 1600, 20 square is equal to 400, and 30 square is equal to 900. But 400 plus 900, that is the squares of the smaller numbers, on adding is not equal to 1600, the square of the greater number, which is 40 square. Therefore, 20 square plus 30 square is not equal to 40 square. Therefore, the above expression is not of the form hypotenuse square is equal to base square plus height square. Therefore, the sides of lengths 40, 20, 30 will not form a right angled triangle. So this way we have completed our practice set 49 and also the chapter Pythagoras Theorem. So do practice the sums well in your notebook. Stay safe, keep learning, and thank you.